Go through it. Make sure you pay attention, especially if you had D as your answer. All right. If parallelogram. If this is a parallelogram, which one of these statements is true? Who got which one's true? Yes.
D.
D.
I did not get that.
What other answers did we get? Yeah.
B.
So B might be a possibility.
FG is not.
So it's either B or D, it sounds like. So it can't be A or C, I guess. We'll figure it out. So let's make a parallelogram. We will call it E. And it doesn't matter how you order it as long as it's in order. So you could have did E, F, G, H, just had to be in those proper orders. Well, E it doesn't have to equal F, because only E just has to equal G. F, G does not have to be parallel to GH. In fact, it can't be because they intersect. B says angle F is congruent to H. F is congruent to H. I agree with that. The last one says E plus G, which are the exact same, equals 180. It does not necessarily have to equal 180, so it has to be B. Yes?
When I made, I feel like the top one, the top left was E.
Okay. Let me start where you started from. So top left, you made E.
Yeah, and then
Okay.
top right, I made F.
Which would make the next one have to be G
Oh, that's.
and then H.
Oh,
Has to go clockwise or counterclockwise.
oh,
You can't change your directions.
so G and H.
Yeah. All right, our next one, we are supposed to find all of these values. It is a parallelogram. So the easiest ones to find are the ones that are alternate interior. So if this is 56, V is 56. If this is 26, U has to be 26. Now we're kind of stuck unless we have this 8 and 8. And since we have 8 and 8, it's an isosceles triangle. Isosceles triangles have base angles that are the same. So W is also 56 degrees. How can I use this 56 to get me to Y? Can someone help me out? Yeah.
Use the convert. You could do 180 minus 56.
Sure. Which would equal
124.
124. And if that's 124 degrees, and this is 26 degrees, that means 150 degrees are taken up by these two. What does Y have to be then? Amber? Has to be what? 30 degrees. Yep. So that's 30 degrees. Now, here's how we get to X. There's a couple ways we can get to X. We could figure out this measure and say it's 180 minus that measure, or, Lydia? We could use vertical angles to say that's 56 degrees as well. So this is 56 degrees, this is 56 degrees. What does this have to be then? Robin?
68.
68.
I have a question.
Yeah.
Can you also just get from the two 56s from the other triangle, and then since the two lines are parallel, the 8 and 8 are parallel, and then it's alternate interior and stuff? Can you do that?
Yes.
That works, yeah.
Yeah, I see what you mean. Yeah, that's possible. So it has to be 68 degrees. Yes?
Can you assume the midpoint in this case?
Can we assume it's the midpoint in this case?
Or where the middle of the X?
It has to be.
It has to be because they bisect each other. And if that's 8 and 8, yeah. Because the definition of parallelogram is this has to bisects this, so this has to be 8. Yep. Which means, and this has to be 8 as well because of these sides. So bisecting, they definitely bisect. So we should have 68 degrees. Any questions on those? Okay, then questions from the homework. Let me see if I can find the homework so I can answer questions. Sabrina.
For number, there we go. Number, 21 and 22.
21 and 22. Do I have the wrong sheet here? Oh, no, I don't. All right, 21 and 22. What values must x and y be in order to make the quadrilateral a parallelogram? I wonder if I have them up here. All right, in order for it to be a parallelogram, opposite sides must be congruent. So we just have to say that this side has to equal that side, so it's 4x plus y equals 42. And this one is, this has to equal that, so that'd be 3x minus 2y equals 26. So now we're either going to use substitution or elimination to actually solve it. I'll just start that. What I would do is I'd probably multiply this one by 2, which is probably what I did in my notes, which would be 8x plus 2y equals 82 all over 3x minus 2y equals 26, which would give me 11x. That would turn to 0. That's going to equal, wait a minute. Why do I feel like I made a mistake?
84.
84, there you go, thank you. I was like, that doesn't work out to what I thought it was going to. It should have been 84. I forgot to multiply it by 2 fully. So that's going to be 110, so x would equal 10, and then you're going to get y by yourself. Same thing's going to happen over here. You're going to set this equal to that, and this equal to that. Yeah.
Also, I caught a mistake at the answer key.
On these two?
Oh, not that. On the like there was supposed to be some like I can't find it now, but it was this plus this and equals that, but there was an addition sign between one of the problems.
I'd have to know which one. That isn't much to go on. See if fine. Otherwise, I'm going to ask Evan.
Right there.
Oh.
In number 20, it says y and in blank 6 and y plus 5 equals 0.
Y minus 6 times y plus 5. I have y minus 6 and y. Maybe it just didn't scan properly. Yeah.
My printer.
Oh, okay. Yeah, it should say y minus 6 times y plus 5.
Oh, okay.
It's very light, so I assume. Okay, Evan.
Oh, I know you just pointed to how to set up 22, but I couldn't see.
Oh, okay. Let me just take a picture. Okay. So to set it up would be something like 4x
Is it
Plus-
going across?
equals 9y, because it's alternate interiors.
Oh, okay, I got it now.
And then the other one.
Okay.
All right, other questions? Lydia.
Can you walk through number 3?
Number 3. Sure. No. You need both pairs of opposite sides. This number 3?
No.
Okay.
Proof number 3.
Okay, okay. I was like, there's not much to walk through, it's just no. There's not much more I can walk through. That is theorem 5-6? Is that the tough one? Yeah. So, just so you know, I'm not going to put that on the test. I'm going to put one much harder on it.
That's better. The exam's gonna use
It's going to be a harder one.
5.65.
Yeah, I'll pick a harder one this one. Obviously, this is too easy. Okay, here's the problem with these proofs and why they're so difficult compared to the ones after when we can actually use these theorems is because you can't actually use the theorem to prove it. It's kind of like when you have a difficult word to describe, and sometimes you just want to use that word to describe it. Like aardvark. What's an aardvark? I don't know. It's an animal named aardvark. Whatever. So these can be really, really difficult because you have to kind of find tricks to how to solve it. And for this one, I labeled mine A, B, C, D, and because opposite angles are congruent, that's what I started with, that it's given. Then I went ahead and said, well, if I added all the angles together, they'd have to equal 360 because it's a quadrilateral. They have to equal 360. And then I replaced C and D with A and B so that I have them all in the same types of letters. Basically A plus B plus A plus B still equaled 360. That means I have 2 of each of these. So it's 2 times A plus B equals 360. divide both sides by 2, and I have that A plus B equals 180. The whole goal is since A plus B equals 180, this line has to be parallel to this line because they're same side interior angles and they are supplementary. And then I said use the same method to prove the other ones, and then it has to be parallelogram. So it wasn't made to be easy. It was made to be confusing. You kind of look at it and see if it makes sense or not. Oh, good. Good. Yeah, Sabrina.
For number
Is it on this one?
no.
Okay. Yeah.
This way of work that I did, I made like a transversal. And so like that was congruent to that.
But there'd be no way to prove those are two congruent. Because as soon as you'd have to know they're parallel for that transversal to be alternate interiors.
Okay.
Okay.
Did you just do like the same thing just in like 7 steps? Like without saying like the same method, like just like put those all in step 6?
So in step 6, say they're both parallel. Oh, you kind of combine everything?
Well, I only combined 6 and 7.
Oh, okay. At some point, did you say and same method for the other one?
No, I just put like that. I put that step also in step 6, saying that says that here angles are supplementary.
No. That's implying that these steps apply to DCAB. Exactly. By doing this extra step that says same method, because the other method would be changing all these to C's and D's. That'd be the other method. I have to change these to C's and D's. Just because only one transversal exists for each same side interior. It doesn't prove both of them. All right, other questions? Yeah,
Number 20.
number 20. Let's see if I can just bring it up. Did I already have it? No. Oh, there's number 20. So number 20 is what values would make this 100% true? So you'd have to do y squared equals y plus 30. And you have to do 3x minus 40 equals x. The only one difficult to solve is the y one, because you'd end up with y squared minus y minus 30 equals 0. And you have to reduce that to y minus 6 times y plus 5 equals 0. So your y can either be 6 or negative 5. Your x is just going to be one answer.
Okay.
Both those answers will work for this. So your y will have 2 different values. Is that good? I know I'm trying to kind of rush through it.
Yeah, no.
Okay, other questions? Quick, yeah.
Number 3, on the sheet 118, page 118. The answer was no because of the opposite. There were no because of the opposites. I put down yes, theorem 5 and 7, but I don't get why it would
Read theorem 5.7 to me.
the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram.
Okay,
And I thought that they did bisect each other.
one bisected. Do we know that this one is bisected?
Yeah, because it crossed.
Because it crossed.
Yeah, it crossed the other line.
Bisect means it cuts it right smack dab in the middle.
Oh.
I know that this is congruent to that, so this is bisected. But I do not know that this line is bisected. I don't know for a fact that this is congruent to that. So the only time you could do that is on 4. Do you see how 4 has this is congruent to that and this is congruent to that?
Yeah.
That is bisected. Both lines are bisected. All right, if you have other questions, feel free to stop by after. We just need to move on because we are struggling for time right now, but we'll kind of rush through. So we have theorem 5.8. Theorem 5.8 says if 2 lines are parallel, then all points on one line are equidistant from the other line. I think that basically makes sense because if you're parallel, you're always the same distance away from the other line. Right? Can we picture that? If I'm on a line and they're parallel, they're always going to be the same distance away from each other. So, if L and M are parallel, that must mean, somehow I'll put that, based upon this, if L is parallel to M, then AC must be congruent to BD. Yes?
Wouldn't that not be true if you drew like a diagonal line?
BD, do you mean?
Oh, I meant BD. Sorry. Yep, I meant BD. Yes, it would be true if I drew that one. It would have to be that BD. Because it has to be the same. Because it just says the distance. Distance always implies a right angle from the two. Because you're not going to say the distance from me to you is me drawing a curved line around it. It is the most direct way to a point. So the distance here would be straight up, just like the distance here would be straight up. However, it would be true, and we'll find out on the next one, that if I had an angle, and I had the exact same angle over here, then they'd be the same length too. All we're saying is two parallel lines are always the same distance apart. That's all this theorem says. Two parallel lines are always the same distance apart. So if you want to boil it down to that, that's all it means. Nothing too outrageously special. This one pops up with questions though. It says if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Blah. So let's look at that drawing. Let's label these lines really quick. I'm going to label them L, M, and N. Now I'm going to start with since L is parallel to M, which is parallel to N, which means all three of them are parallel together. So we're starting with since L is parallel to M is parallel to N. So we're going to start with that statement. Now I'm going to say if EF is congruent to FG. If EF is congruent to FG and all three of these lines are parallel, note this is one transversal, this is another transversal. So if this segment is congruent to this segment, that means this segment is congruent to that segment as well. So if E is congruent, or EF is congruent to FG, then AB is congruent to BC. So all I'm saying is if three parallel lines are exactly the same distance apart, then whatever line I cut will cut in the same angle. That's all it's saying. If parallel lines are equal distance apart, right, EF is congruent to FG, then any line I draw on there will also be congruent, no matter how angled I do it, which kind of leads to that angled comment if you had angled ones. Grace, I think you have to take off.
Oh, thank you.
Flying? Is it flying?
All right, 510 gets a little more interesting. It says a line contains the midpoint of a line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side. Let's break that down. So it says a line that contains the midpoint of one side of a triangle and is parallel to another side of the triangle through the midpoint of the third side. So what we're going to do is we're going to draw a triangle. See those two little green lines? We're going to draw a triangle kind of like this. Our goal is that this is congruent to that. And we're also going to make the two lines parallel to each other. So based upon this drawing, let me label this real quick. Let's label this A, B, C, whatever. We'll call this M, and we'll call this N. M's the midpoint, right? Based upon my drawing, is M a midpoint?
Yes.
You seem unsure about it. Yeah, it has to be. These two things are congruent. So M is a midpoint. This is a midpoint. So we're basing this on two different things. We should probably pick two different things besides M and N. Let's call this line G and line F. So G and F are parallel. G is parallel to F, and M is a midpoint. Then we automatically know N is also a midpoint. So G and F are parallel, and M is a midpoint. Then N is also a midpoint. That's all it said. So if you have a midpoint, and the line cutting through the midpoint is parallel basically to the base of the triangle, or you could have it sideways, it could be like that, or it could be upside down. But you're looking for, is there a parallel line cutting through one of the midpoints? Because then it automatically is cutting through the midpoint of the other line. That leads us to an example like this. It says find AC. Now we can't find AC until I know for a fact those two lines are parallel. So to find AC, we're going to first, maybe we'll put a little line through this so we know we're doing something else. We are going to say, we're going to let MN be parallel to BC. And why can I let that based upon those numbers? How do I know that's true? Yeah.
The 120 and 60 are supplementary because they're the
Same side interior. Let's say that. So I'm just gonna put same side interior, and that's from that 60 and 120. So I know for a fact that's true. Is M a midpoint? Yes. Yeah, M is a midpoint. It's 6 and 6. So if M is a midpoint, is N also a midpoint? Does it meet our criteria? Are the two lines parallel?
Yep.
Is one of them midpoint? So then the other one must be a midpoint. So AC is going to equal what? Yes.
14.
Equals 14. So AC equals AN plus NC, which equals 7 plus 7, which does equal 14. So that's the type of problem you're looking out for. You're looking out for ones where it goes to the midpoint and it's parallel to help you solve. All right, any questions on that one? Those can be really tricky to see because sometimes, like I said, it'll be put on its side. All right, everyone look up right here. You might see something that looks like this. It doesn't matter which direction it is, whatever direction you turn on the page. If you need to, turn the page. Like if you're like, oh man, does that fit that criteria? Just turn the page until your base is that way. All right, if you need to. These can be tricky to see sometimes. All right, theorem 511, the segment that joins the midpoints of two sides of a triangle. This is basically based upon the other one. So the one before said if two lines are parallel and it goes through one midpoint, it goes to the other midpoint. This one says, hey, if we have a line going through both midpoints, it is both parallel to the third side and it is half as long as the third side. So that this is only true if this is a midpoint. And n also has to be a midpoint for this to be true. I don't think I put a ton of notes here. No, I didn't. I just want you to realize this is really important. It gets used a lot. It gets used in the test. It gets used a lot in the homework. If this connects both midpoints, it is parallel and it's half the size of the base, basically. So if our base was 6, this line would be 3. If this was 10, this line would be 20. All right? So the lines that connect the midpoints is going to be half as long as that base side or that side opposite, kind of. All right? Are we okay with that? Okay. All right, let's put that in practice real quick, because we're going to practice. Because I think this one's important and it's easy to miss. So this one says PQR are the midpoints of the sides of a triangle DEF. So P, Q, and R are all midpoints. This one says how long is PQ? So real quick, we're going to look at PQ. P and Q are midpoints, so that means that this line is parallel to that line. Automatically. It goes to midpoints, it must be parallel to that third side. Now if PQ, I mean what's the size of PQ? Let's just end there. Yeah.
Oh, 4.
4. It is going to be 4. Because PQ equals half of DF. So PQ just equals half of 8, which is 4. And it's conveniently written over here, so you got it right. It is 4. That length is 4, it's half. 8, 4. How long is RQ? RQ. RQ. 2 people, 3 people, all right. 4 people, 5 people. Oh man. Woof, woof. Yeah, Stephen.
6.
It is going to be 6, are you sure?
Yes.
Yeah. So RQ is this line, which is parallel to this line. It does connect the midpoint, so it's got to be half of 12, so RQ has to equal 6. Yep, that is correct. So that's 6. That's 4. What's this length? What's P to D? Yeah, remember. 6, because it's midpoint, right? So G to P. What's D to R? What's the length of D to R? Akshay? 4. What kind of figure is something that has opposite sides being congruent? Both opposite sides are congruent. Yeah. It's a parallelogram. And what is the perimeter? Yep. 20. Because it's 6 plus 4 plus 4 plus 6 equals 20. All right, that is all. Yeah, sorry.
What? So look at the parallelogram. What if you're trying to find FQ or QE?
FQ. FQ. Oh, FQ is going to be half of 10. Because it said that Q is the midpoint. So yeah, FQ would be 5. I think this is pretty cool. That if you connect all the midpoints, it creates a parallelogram. It's kind of cool. What was that?
No, I actually wrote the thing above that. Now I'm like,
Oh, okay. Yep. All right, any other questions? Everyone looks bored of hearing me talk, so let's go ahead and just start working.